Okay, welcome back. So in this video, what we're going to do is we're going to try and grab the characters that were written by the printf that we were working on in our last video. So in this particular thing, we're going to try to look at using the console that's available inside of CubeIDE. There are other ways you could get this serial data. You could use, PuTTY or TerraTerm or any number of terminals that are available. And if you're on Linux, you could use Screen, Windows OS X or Linux. You can use Screen. Any of those are legitimate ways to get the serial data. I'm going to show you how to do it in CubeIDE because I think it's probably a little less clear in CubeIDE than using these other tools, these external tools. And this will keep it all within the same environment, which can be nice sometimes. All right. So the first thing you've got to do to make this happen is you got to go and figure out, when you plug your Nucleo board into your system, you got to go out and figure out what the device ID is. How did it, once the device driver was loaded for the endpoint that is a serial port on that Nucleo board, right? There are 3 endpoints on the Nucleo boards. There's a bulk device so that you can drag, that makes it look like a drive, like a thumb drive. You can drag and drop ELF files into it, and it'll just program them. There's a debugger interface, which we used a couple of videos ago to manipulate the board, to start and stop it, and to download code, all that good stuff. Basically interact with it using GDB. And then the third thing that it's got is is serial port. So it exports a virtual COM port, right? So this is serial data that's flowing over USB, and so but it looks like the sort of old school COM port, And so in Windows, the way you go and figure out, well, what COM port is this using? So they'll be numbered sequentially. And so this one, to figure it out, you go into something called the device manager. And so I've already brought up the device manager. You can go into your control panel and figure out how to get to it. But I've got device manager up. It may complain at you that you're not the administrative user. That's okay. And if you're on Linux or on Mac OS, you can go into /dev and look at the device that it enumerated as, something like TTY USB 0, maybe if it's on Linux. And then in Mac, you can go and look at what the COM port enumerated as when the device was created. So I'm over here in Windows, and if I look at the ports, I'll see these are the ports that I've got on my system. And so this device came in as a COM6, and I'll just squirrel that away in my brain and just remember that it's COM6. All right, so, okay, the next step is now that I know what COM port it is, I'm gonna come back over to Cube, and I'm going to come down here into this window down here, and I'm going to click on this little thing right here that's going to create a new console view. And so I'm going to pull it down. I'm going to say I want a command shell console, and I'm going to change this to serial port, and I'm going to change new. And so we're going to call this ST-Link COM port, and it is on COM6. And this is the right baud rate. If you remember in the earlier videos, we went and kind of looked at it, and we were looking at what the baud rate was. And so data size is 8. That's fine. No parity, 1 stop. That's fine. And these are all parameters that are configurable that we would have configured when we ran that. We ran this this MX UART2, UART init. You'll see that all these properties are in there. So I'm going to finish that. And I'm going to say, okay. And so now I've got a COM port there. Okay, so now that I've got this COM port, let's go and go ahead into the debugging perspective so we can run this code. Remember, if you remember from last time, we integrated in this init for the retarget, and then we called printf. So we're looking for us to get this message out here. All right, so I'm going to go into debug perspective. And I'm going to get my ST-Link COM port device over here. So I'm going to go over here to the right, and I'm going to grab it. Okay, there's nothing there, which we would expect that, right? Because we haven't actually run that code. So let's just go ahead and let it rip. So, it's going to hit this first breakpoint. So when we hit go, it'll hit this first breakpoint. If we don't like that, we can come over here and we can, disable it, or we could even delete it if we really don't like it. So we can remove this guy here if we don't like it. Now it's gone. So now if we were to reset, we could run it again. We don't hit that breakpoint. So let's resume. And there's our message system up and running down here. So in our terminal with the cursor sitting right there because of this /nr. So what's the code doing right now? Well, it is doing nothing. It's sitting in this while one, just looping and looping and looping. And so if we stop it here with the pause, you'll see that that's where we're at. We're sitting in this while one, which, if you come over to the disassembly, it's literally sitting at this instruction and just cranking on an instruction that loops back on itself. Notice this is a branch to this address, which is this address right here. So it's doing nothing. And so not that doing nothing is unimportant, because down the road when we start talking about interruption, doing nothing's okay in this particular thread of execution. But then when we we get an interrupt, we'll jump to some other thread of execution. And so that's okay. All right, so that's basically, now that we've got the system up and running, we've got the ability to send characters. You can type in this and receive characters. So we've got a platform to start working on building a command interpreter.